Very good morning, friends. Myself, Dr. M.H. Annaya, and in today's video, we are going to work out a problem on an eccentrically loaded riveted joint. The joint is as shown in the figure, and friends, you have got 1, 2, 3, 4 rivets, distance between them being given. And these four rivets are displayed to say is riveted to a vertical plate and it has to sustain a load of 10 kilonewton. And friends, here we have a definite procedure how to work out a problem on eccentrically loaded riveted joints. Basically, you have to start from the location of the center of gravity or centroid of that rivet system. Friends, if you see, this rivet arrangement is symmetrical about this line, this vertical line, because you have the same distances of all these. All these four rivets are, say, rivet number, say if it is 1, distance of 1 and that of 4 are the same, 2 and 3 are the same. Hence, this becomes the centroid of the rivet system, which we call it as G. Once you have located G, friends, the distance between the load axis and the center of gravity is represented by E, the eccentricity. And in this problem, you can see this eccentricity is at a distance of 100 plus 100 plus 200 by 200. So totally, this E is at a distance of 300 millimeter, or the load is acting at a distance of 300 millimeter from the centroid of the rivet system. So in the first step, we have located the centroid, and in step number 2, friends, we are going to find out what is the direct load. The direct load, we call it as, say, FD, the direct load. Friends, the load of 10 kilonewton is equally shared by all these four rivets. I'll just call these rivets as 1, 2, 3, and 4. So the load shared by each of these rivets will be equal to the total load, that is 10 kilonewton, divided by 4 rivets. If there are 5 rivets, you have divided by 5. So this becomes 10,000 by 4 is 2,500 Newton. So this is the direct load, the shear load acting on all these 4 rivets. Its value is same at each rivet. So friends, then you should know how to represent this direct load. So friends, this direct load FD acts at the center of each rivet parallel to the applied load and in the direction of it. So 10 kilonewton is acting downward. So at this point, the load F, the P1 or FD should act downward. This at this point it should act downward. Each is equal to 2500. And similarly at rivet number 3, it is 2500. That is FD. Again at rivet number 4 is 2500 Newton. So this is how the load acts. You can see this FD is acting parallel to the applied load and in the direction of it. In the direction means the load is acting downward. Here also FD is acting at the centers of each rivet in the downward direction. Now friend, step 3, in step number 3, we are going to find out what is called secondary load. The secondary load due to eccentricity. So friends, this will call it as FS. So there are 4 rivets. We will say the load, secondary load at rivet as F1, at 2 F2, at 3 F3, and at 4 F4. Friends, to find out this secondary load, we have an equation given by P into E is equal to F1 by L1 multiplied by L1 square plus L2 square plus L3 square plus L4 square. I'll tell you what are these. Friends, P is the load, that is 10 kilonewton, 10 into 10 to the power of 3 Newton. Eccentricity is 300 millimeter, that is balanced by F1, the secondary load at rivet 1, divided by L1, L2, L3 and L4. What are these? Friends, L1 is the distance of rivet number 1 from G. So this is L1. So L1 very obviously is equal to 100 plus 100, 200. So write down here L1 is equal to 200 mm. And then L2 is the distance between center of gravity CG and this rivet 2. So this is 100. Similarly, L3 is this gap, distance from G to rivet number 3, that is 100. Finally, L4, distance from G to this rivet, it is 100 plus 100, 200. So we have found out these values of the distances of all these rivets from the center. So friends, here I will substitute L1 is equal to 200. And here inside the bracket, friends, you can see L1 is equal to L4, L2 is equal to L3. So we can call this as 2 times L1 square plus 2 times L2 square. So L1 is 200, L2 is 100. So we know all these values. Friends, you will be able to simplify and obtain what is the value of F1, the secondary load at rivet number 1. So we will be able to find out this value F1 is equal to 12,000 Newton or 12 kilonewton. So 12,000 Newton is the load. So after finding out this F1, we should know how does this load act and where does it act. Friends, all these secondary loads F1, F2, F3, F4 acting at rivets 1, 2, 3 and 4 act perpendicular to this line, perpendicular to this axis, so as to produce a moment similar to that produced by this P about this G. So friends, if you take the rivet number 1, F1 should act vertical, that is perpendicular to that line, say L1, and this F1 should produce a clockwise moment about G, because P is producing a clockwise moment about G. Similarly, friends, F2 acting perpendicular to this L2 should produce a clockwise moment. You can see this is producing a clockwise moment. Then friends, F3 acting here should produce a clockwise moment, that is about this point. About G it should produce a clockwise moment. So also the final load F4 should produce a clockwise moment. And we can just say that the secondary loads act at centers of rivets 1, 2, 3 and 4 so as to produce a similar moment as that produced by P about the centroid or center of gravity G. Friends, we have marked the direct load and the secondary load acting at each of these rivets. Next, friend, we have to identify in step number 4. We identify which is the heavily loaded rivet amongst these 4, or on which particular rivet the load is maximum. So it all depends on the arrangement of rivets. It could be one rivet or two rivets. And how to identify that? Friends, if you take up this first rivet, direct load is acting downward, secondary load is acting upward. The effective load on this will be difference of FD and F1. So if F1 is 12,000, this is 2,500, there will be a net load acting, that is 12,000 minus 2,500 acting upward. Similarly, if you take the second rivet, the load acting on secondary with direct load is 2500, secondary load is F2, and to find out this F2, friends, there is a relation F1 by L1 is equal to F2 by L2 is equal to F3 by L3 is equal to F4 by L4. So the loads F1, F2, F3, F4, etc. are proportional to the distance of those fluids from the center of gravity. So here, friends, the effective load will be difference of these two. Here, friends, what happens at rivet number 3, the resultant load, I will call this as Fr, which is equal to FD plus this Fr3 or F3. And finally, friends, the resultant load at this point, say R1, and here the resultant load will be F4, the direct load, secondary load plus that 2500. So, friends, from this analysis you can see either rivet number 3 or rivet number 4 are critically loaded, because both the loads are acting in the same direction, and these two get added up to give the resultant. So we can take these two separately and check which of these two. I can say this is FR1 and this is FR2. Resultant load at the rivet number 3, this is rivet number 4, you have to see. Fourth rivet 4. So friends, we will find out this separately and check whether 3 is critically loaded or 4 is critically loaded. Friends, for rivet number 3, FR3, resultant load at rivet number 3 is FD plus F3. So FD is 2500, we have calculated in the first step, and this F3 you will have to find out. I told you F3 by L3 is equal to F4 by L4. So I am interested in F3, therefore F3 is equal to F4, which is also equal to F1 because the distance is same. F1 by L1. What is L1 here? It is 200. So F3 is equal to F1 by into L3. L3 value is 100. So this resultant will be half of that. That is 0.5 times F1. The value of F1, friends, you have seen is equal to 12,000. 12,000 by 2 is 6,000 Newton. And similarly, so this you write as 6,000 Newton. And similarly, for rivet number 4, the resultant load at rivet 4 is equal to F4 plus the direct load FD. So F4 is equal to how much? We calculate this F4 by L4, the formula F4 by L4 is equal to F1 by L1. Friends, F4 is equal to F1. F1 you have calculated as 12,000 multiplied by L4. L4 is 200 divided by L1 is 100. Friends, this works out to 24,000. F4 is equal to F1 into L4 divided by L1. Yes, this is 24,000 Newton. Friends, very obviously, by comparing this FR3 and FR4, you find that the value you can just add up here. So this FR4 will be 24,000 plus 2,500. So it comes to 6,500. Friends, this is the maximum load or the resultant load acting at rivet number 4, which is very closer to the load applied here. Friends, you can see here from this analysis we can find that rivet number 4 is heavily loaded. Rivet 4 is heavily loaded or critically loaded. And after finding out this resultant load, friends, you will have to find out what is the size of the rivet required. Friends, we are going to equate this resultant load to the shear strength of the rivet. So I am going to equate F4, the resultant load, to the shear strength of that rivet. So pi d square by 4 into tau. So this is known as 26,500. That is equal to pi by 4 d square, and the shear strength is given to be 60. Friends, you will be able to find out what is the diameter of the rivet required. Friends, this is how we obtain the diameter of the rivet required in a eccentrically loaded riveted joints. Friends, if you are happy with the presentation I have made on this eccentrically loaded riveted joints, do share this information about my video to all your friends. Please go through the complete video, and I thank you very much for watching my YouTube video. Have a wonderful day.